So today we're going to be learning about systems of linear equalities. Inequality. An inequality is different in size, degree, and circumstances. A solution of an inequality is a value or values that make an inequality true. Slope-intercept form is y equals mx plus b. Less than or greater than is a dotted line. Less than or equal to or greater than or equal to is a solid line. Shading. If y is less than or equal to, shade below the line. If y is greater than or equal to, shade above the line. Shade on one side of the line for each of the equations. The shaded region represents the solution to the inequality. Here's how you graph a linear inequality. First, solve the inequality. You always want to put the inequality in slope-intercept form no matter what. Second, graph the line. Use a solid line if it is less than or equal to or greater than or equal to. Use a dashed line if it is less than or greater than. Finally, shade above the line if y is greater than or equal to. Shade below the line if y is less than or equal to. So in this problem, we have y is greater than or equal to negative 3x plus 4. I'm going to show you guys how to graph it. So first, you want to graph on the y-intercept, which is 4. Graph 4 right there. Sorry, my bad, dots. Then, you want to go down 3. So you go 1, 2, 3, over 1. Put a dot there. Then you go down 3 again from that point. 1, 2, 3, over 1. Let's do one more point. Down 3 again. 1, 2, 3, over 1. And then you're going to graph a solid line through them. And since it's greater than, you're going to shade up. And all the parts where I shaded, that'd be the solution since it's like greater than or equal to. On this problem, it says y is less than or equal to 3 over 5x minus 5. So first you want to graph the y-intercept, which is negative 5. Right there. Then you're going to go up 3 from that, so 1, 2, 3, then over 5. 1, 2, 3, 4, 5. And then you're going to graph a solid line since it's y is less than or equal to. And since it's less than, you're going to shade down. And these would be all the solutions. All the solutions where I shaded, those are solutions to the graph. In this problem, it says y is greater than negative x minus 5. So first you want to graph the y-intercept, which is negative 5. Then you want to go down 1 over 1. And since you can't go down anymore, you're going to go up 1 from the y-intercept, then over 1. Then up 1 and over 1 again. And since it's less than and not, since it's greater than and not greater than or equal to, you're going to want to graph a dashed line. And then since it's greater than, all the solutions shading above the line are the solutions to the graph. So everything above this dashed line will be the solutions to the graph. For number 4, we're going to be graphing y is greater than negative 4. So first you want to graph the y-axis, which is negative 4. Just draw a dot down negative 4. And since you're graphing y, you're going to graph a horizontal line all the way across. And since that's greater than, you're going to do a dotted line. So just do a dotted line all the way across. And since it's greater than, you're going to want to shade above the axis. And all this area where I shaded with the solution of the graph. So right here where I just circled. So in this problem, we have two equations as a system. So first one is y is less than or equal to negative x minus 2. So first you want to graph negative 2. Then you want to go down 1 over 1. Down 1 over 1. Down 1 over 1. And since it's less than or equal to, you're going to graph a solid line all the way across. And since it's less than or equal to, you're going to want to shade down. Then for the second one, I can use a different color. And it says y is greater than or equal to negative 5x plus 2. So first you want to graph the y-intercept, which is 2. Then you want to go down 5. So 1, 2, 3, 4, 5 over 1. And since it's greater than or equal to, you're going to graph a solid line. And since it's greater than or equal to, you're going to shade up. And these right here where I overlap, where the two graphs overlap, are the solutions. So this little corner right here to be all the solutions to this graph since the shadings overlap. For the second one, we have another system of equations. And the first equation is y is greater than negative x minus 2. So first you want to graph the y-intercept. Then from there you're going to go down 1 over 1, down 1 over 1, down 1 over 1. Since it's greater than, you just want to do a dotted line all the way across. And then since it says greater than, you're going to shade all the way up. And for the second one, it says y is less than negative 5x plus 2. So you're going to go up 1, 2. Graph start at the y-intercept. Go down 5. 1, 2, 3, 4, 5. Over 1. Then you're going to graph a dotted line to this less than. And since the graph is less than, you're going to want to graph down. And right here in this little corner in the top of the left axis would be all the solutions since the shadings overlap each other. For this So in this problem, we have a system of equations. Y is less than or equal to 1 over 2x plus 2, and then y is less than negative 2x minus 3. For this one, you're going to try it by yourself, pause the video, come back, do it, and then I'll show you how to do it. So now that you have solved the problem, that's what you should have gotten. For the first line, you're going to want to shade down towards the bottom of the y-axis. And for the other one, you're going to shade down. And where they overlap is the bottom corner of the left of the y-axis. Right there where I circled. For this one, we have another system of inequalities. The first being x is less than or equal to negative 3. The second one being y is less than 5 over 3x plus 2. Pause the video and solve this, then come back when you have solved it. My answer will be there and compare the two answers. So for the first line, x is less than or equal to negative 3. You're going to graph at negative 3, then graph a vertical line straight up on the y-axis. You're going to graph to the left side since it's less than or equal to, and shade to the left. For the second one, y is less than 5 over 3x plus 2. You're going to start at 2, go down 5 over 3, then shade to the right. And then where the overlap is a solution, right in the bottom left-hand corner, you see those are the two solutions because the graphs overlap each other. So for our final problem, we have a word problem. And it says, Sarah can spend at most $7.50 on vegetables. Broccoli costs $1.25 per bunch, and carrots cost 75 cents per package. Write a linear inequality and graph the solutions. So first, you'd want to write 125x, which represents the broccoli, plus 75y, which represents the carrots, is less than or equal to, since you can't go over there, 750. Then you're going to simplify it, so you're going to do 75y is less than or equal to negative 125x plus 750. Then you want to divide by like terms, and you end up getting y is less than or equal to negative 5 over 3x plus 10. Then you're going to graph from here. So I'll do my graph in the corner over here. So you're going to go up 10. I'll say this is 10 right here. Then you want to go down 5 over 3. So let's pretend down 5 over 3 around here. And you want to make a solid line since it's less than or equal to. And since you're graphing down, it's going to look like this. So pretend it's like a line. It's like a line graph. You're going to make a triangle. You're going to end up shading down like this. And that would be a solution. All the solutions down from that graph.